Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
Robots explore the world and help clean our house. They do a lot, but how? And what is the science behind robotics? We're here to find out and to answer your questions. Stay tuned. Science Trek is next. Hi, I'm Joan Cartan Hansen, and welcome to Science Trek, and welcome to Micron Technology. Here, workers use robotic equipment to help build some of the world's most advanced memory and semiconductor technologies. We're here to answer your questions about robots. But before we do, let's learn a little bit more.
Thank you, Mitt. What's our assignment for science this week?
We're supposed to learn about robots.
Great. Mitt, can you help us learn about robots?
Robots are human-made machines that can perform work and other actions. Some work automatically, some by remote control. Robot comes from the Czech word robota. It was first used in a play in the 1920s. Inventors have been building self-operating machines for centuries. These automata were run by clocks or moving water. The first electronic robots were created in England in the 1940s. By the 1960s, robots were used to move things around, like in a car plant. Robots generally have three main parts: a controller or a brain. This is the part that tells the robot what to do or where to go. Next are the mechanical parts. These are the motors, wheels, gears, grabbers, whatever, that make the robot do its work, to grab or turn or to lift. The third are the sensors. These are the devices that allow the robot to figure out size and space, where to go, or how tightly to grip. Together, these three basic parts make up a robot. Robots are sometimes used where work is repetitive, that is, the same task being done over and over again. They're also used in places that would be dangerous for people. NASA uses all sorts of different robots to help us explore space. Rovers on Mars are mini laboratories, helping humans learn about the Martian soil. These robots at the Johnson Space Center help teach new astronauts how to do things in space. Robots come in all shapes and sizes. Some are as small as insects. These are called nanobots or kilobots. Some scientists are designing robots that show emotion, and some are working on robots that think. Scientists are just starting to figure out all the different things robots can do. So whether they're helping us out at home or traveling deep into space, robots are changing our lives.
Well, that was very interesting. Mitt, stop bothering the Roomba. You know that can't dance.
And joining me now to answer your questions about robots are Dean Klein, Vice President of Memory Systems Development here at Micron, and Josh Johnston, a research scientist at Boise State University. Thank you both for joining us.
Thanks, great to be here.
Thanks for having us.
Okay, let's go to your questions.
Hi, my name is Taylor and I go to Galileo, and my question is, who was the first person to build a robot?
That's a difficult question, actually, but let's back up and maybe let's define the word robot first. The term robot was first used by a Czechoslovakian playwright in a play called R.U.R. And robot was used to, it was a term for an automated humanoid that was a slave. And the actual root of the word is a Czechoslovakian word that robota or robotnik, which means slave. So I think the first robot was probably in a play in 1921, in the play R.U.R. in Czechoslovakia.
Hi, my name is Caden. I go to Galileo STEM Academy, and my question is, how many different kinds of robots are there?
Well, there are a lot of different kinds of robots. We usually think about robots in terms of what environment they operate in. So we have manufacturing robots like the robots that you would see building cars. You also have robots that go places outdoors, and we break those down, usually robots that are in space, robots that fly, robots on the ground, robots on the surface of the water, and robots that are underwater. And within each one of those environments, there's lots of different types of robots that do lots of different things. But usually, a robot's designed to work in only one of those environments, and usually that's the only place that it works.
I might add that in the FIRST robotics program, there are over 10,000 teams worldwide that will build a robot to solve the same challenge. And no two robots are alike of those 10,000. So there's a lot of different types of robots.
Maya asks, do robots have feelings?
So robots don't have feelings the way that people have feelings. Robots are usually controlled by a computer brain, so they have software programming the same way that a computer does, and they respond based on what their programming tells them to do. Now, as we've developed more advanced robots, we have been working with robots that we try to teach to learn so that they can get better as they do tasks over and over again. And some of these robots, we like to talk about feelings as a method for understanding how we're trying to get the robot to work. So we might talk about a robot that is programmed to have a sense of urgency if something needs to happen quickly, or to feel satisfaction if it's performed the job properly. But these are really just terms that we're using and techniques that we use when we program the robots. That doesn't mean that these robots actually feel these emotions the way that people or animals do.
Hi, my name's Michaela. I go to Hawthorne Elementary. I would like to know, how long does it take to build a robot?
I think to make a simple robot like the Roomba vacuum cleaner, those are probably mass-produced in well under an hour. More complicated robots take a longer period of time. In the FIRST robotics program, the teams are given 6 weeks to build those robots, and then those robots get sent off to a competition that's a couple weeks later. The FIRST LEGO League, they can probably build their robots in an afternoon. So different robots with different levels of complexity, different lengths of time to build them.
And my name is Thomas. I go to Owyhee Harbor, and my question is, how do you make the system that controls the robot?
Well, most robots are actually computer controlled, so different types of robots will have different types of computers depending on the complexity of the task that they're working on. This is what's called an Arduino. It's a very popular hobbyist robot control, and you can see it's just got a few chips on it. Very simple, very inexpensive. This would be kind of the low end of robot control systems.
My name's Natalia, and I go to Galileo STEM Academy. My question is a robotic always done through a computer?
Robots weren't always done through computers, but today most robots are, even if the computer is a simple computer like this Arduino board.
This is a question that's interesting because it gets to the idea of what it is to be a robot. So normally we talk about robots as having three major parts: a part that senses, a part that plans, and a part that acts. And that's what makes a robot different from something like a computer, which can think and can process information, but it doesn't really have any way to either sense the world or to actually do something in the world, to go out and move something. If we think about a robot in that sense, there always has to be this planning stage where the robot is thinking. And there have been examples that we can look at in history of mechanical robots, but really for the way that we use the word today, robots are controlled by computers, and robots have computers inside of them.
Researchers created small robots that use bacteria-filled fuel cells to produce electricity. The cells draw energy from rotten apples and dead flies. Their goal is to make a robot that can forage for its own food.
Hi,
I'm Ella, and I go to Galileo STEM Academy, and my question is, how fast is the fastest robot?
I think the Boston Dynamics Wildcat robot claims the title of the fastest robot at 20-some miles an hour. However, the spaceborne robots, like maybe the Voyager spacecraft, would have achieved speeds of well in excess of 40,000 miles an hour. So very fast by comparison.
The fastest robots are actually the fastest things that people have ever made. So the Helios probes that orbit the sun and the Voyager probes that are leaving the solar system are the fastest things that man has made, and they're also robots. So that's one measure of what the fastest robot might be. We also are building robotic cars and robotic planes that are also very fast. If you think about a robot that has legs, then the cheetah robot from Boston Dynamics, it's not as fast as a cheetah, but it is faster than the fastest people are. So that's a good measure, and that robot goes about 30 miles an hour.
Maximo asks, how do robots see?
Robots use lots of different methods to see. Robots will use lasers, radar. They also will use vision just like people do. So this is a vision system from a robot. It's called a stereo vision camera head. It's stereo because it has two cameras, one on each side. This works the same way as our eyes do, using two different perspectives on the world to tell how far away objects are. A robot can use this stereo vision system to build a full 3D model of what they're working with, use that to see obstacles and avoid them, or to see objects that they want to reach out and grab.
Some robots will also use ultrasonic systems and infrared detectors to see their environment.
My name is Lauren. I go to Galileo STEM Academy, and my question is, in the robotic fields, do you think that you guys would be making robots to help us with anything on a daily basis?
So robots right now are already impacting our daily lives, and that's because most things that we buy have been touched by a robot at some point. Things that are manufactured oftentimes have a robot involved in some point of the manufacturing process. Even things like food, where robots are part of the manipulation of food as it comes from the field. As we grow vegetables, they're sorted by robots. They're moved from one place to another by robots. So we don't necessarily go up and talk to a robot every day, but the robots really are already impacting our life in a lot of ways that we don't see directly, but we do see those results.
Robots are sometimes influencing the jobs we do as well. The robots are taking the difficult jobs or the dangerous jobs that we really don't want people to have to do.
Hi, my name is Aaliyah, and I go to Oahe Harbor, and my question is, can robots talk?
So robots do what they're programmed to do, and we can program robots to talk. This takes a few different forms. Sometimes we will program a robot to have a set list of things that it can say. So this might be as simple as saying yes or no. This is the same kind of approach that we use in automated telephone systems, where you call and instead of getting an operator, you talk to a computer. We can put that same type of a system into a robot so that it can give limited responses based on what its sensors are telling it that it should do. In terms of a robot that can just come up with free natural language and sound like a person, this is actually an interesting definition of artificial intelligence that was put out there by a scientist named Alan Turing. And he suggested that we would know that we had artificial intelligence when we could program a machine that would be able to talk the same way as a person. And he defined this as we would not know whether we're talking to the person or to the robot. And that's called the Turing test. So we have robots that can talk, but it's really kind of a playback or saying things that are in a very constrained set of choices. We don't have something right now that can just have a conversation like a person can, although most scientists believe that that is within our reach and that there will be one within our lifetimes that we can have a regular conversation with.
Sometimes robots are built just for fun. A few years ago, scientists at UGOBI showed us how they built Pleo, a baby dinosaur robotic toy.
Robots are used to do lots of things. Some explore space. Some build things. Some are used in places where people can't go to help us see or to fix things or to collect data. Scientists face a lot of challenges when they design and build a robot. The folks here at UGOBI created a robot called Pleo. We visited their offices to find out more.
Why did you choose a dinosaur for the design of your robot?
One of the things is there aren't any baby dinosaurs running around, so we always thought it'd be really fun if you could have a little dinosaur running around your house. And so we chose the Camarasaurus because it has a nice long tail and a long neck, and they're pretty cute. And instead of building a little scale model of a dinosaur, we actually wanted to build a baby dinosaur, and this is just about the size that a Camarasaurus would be 2 weeks after hatching. So if you really could find a dinosaur egg and have it hatch, it would look like this.
How did you start?
Well, once we decided the kind of dinosaur we wanted to do, then we started doing our research and finding out all about this dinosaur. And we actually got skeletal reconstructions from the scientist, and we started measuring everything out and figuring out, okay, since we don't have spines and muscles, we have to use motors. And so we started figuring out, okay, we can put this motor here, and it's got to make this move, and we just kept working until we figured out how to get everything to fit in the space that we have. So this is what our little buddy looks like when he's without his skin. So you start to see the mechanisms, you start to see how the wires run through for him to tilt his tail, and you see his head. You see this little silver strip? That's where he senses your touch on there. And he's got another one on his chin. How his eyes open. Inside of his body, he has these little gearboxes. And each one of these little gearboxes has to be built so that it does all the things. You can see the little motor in there, right inside. Yeah. It's like a little motor, and then it runs all these gears. And that's how he can open his mouth and close his mouth and open his eyes. And all this has to fit inside so that it'll still look like he's supposed to look like on the outside.
Does Pleo feel his joints getting ripped like his neck?
One of the big issues is that when you put something in the physical world like this, then you start thinking about it as being real. And if you have an animal there, any kind of animal practically, except maybe a tortoise, if you touch them, they respond right away. And so that's one of the things that you come to expect. And if we don't have that response to your sense of touch, like if I touch him down here on his leg, I expect, see how he lifted his leg up, we expect him to respond. And if he didn't respond, then you'd think, well, this thing isn't alive. We wanted to make it as close to alive as we could right now. So until we get to the point where we can have sensate skin, we have right now 8 of these touch-sensitive, capacitive sensing sensors. And each one can detect the presence of a hand. It won't respond to things like a pencil. It really wants something like a hand. And so here, there's one back here. A good little Pleo. There's one up here. There's another one on the top of the head. And so if we go like this, then he'll know we're petting him because he can feel this, then this, then this. There's a capacitive sensor under his chin, so we can get that little tickle his chin. On the front of all 4 of his legs, you can see them here, and here, and here, and back here. So those are the 8 touch sensors that Pleo has to detect what you're doing there. There you go. That is one ferocious beast in his own mind.
Hi, my name is Jimena. I go to Galileo STEM Academy, and my question is, what is the most complex robot ever made?
There's a lot of complicated robots, and perhaps some of the space-borne robots like the Mars Sojourner or something, maybe those are the most complex. But I tend to think actually that maybe some of the swarm robots that are actually fairly simple robots individually, but that they work collectively to do a task, those are some of the most complex. Because it's not just one robot doing a task, but it's actually perhaps hundreds of robots doing a task. Here in the factory at Micron, we actually have swarm robots that are moving wafers between multiple pieces of equipment. And they have to work together to make sure they don't collide, to make sure that they get the wafers to the right machine at the right time. And they're not just following their own commands, they're following a collective set of commands.
Matthew asks, can you ever make a robot think?
The definition that most of us use for robots requires that the robot be able to think. So we talk about a robot having three parts. It can sense, it can plan, and it can act. And that planning really is thinking. So by that definition, if we have a machine that doesn't know how to think, then we don't consider it to be a robot. So an example of this might be a door at the supermarket where you walk up, you step on the plate, and the door opens for you. So this has some of the parts of a robot because the door is able to sense that a person wants to enter, and it's able to do something. It's able to move and open the door. But it doesn't really do any thinking about its environment. It doesn't really know what's going on. It has a very, very simple response. So in that sense, we would not consider that door to be a robot. If we talk about a smart house that's able to know that its owner has come home, turn on the lights, turn on the music, unlock the door for him, at that point, we start to see more thinking, which makes us start to think that maybe that house is a robot as opposed to just being a simple machine. So the boundary of what is a robot and what isn't a robot is very complicated, and the ability to think is one of the things that a robot needs to have.
Hi, my name is Riker, and I go to Galileo STEM Academy. And my question is, why are moon rovers and Mars rovers so slow?
The rovers that we send to other planets move slowly for a couple of reasons. One of them is the rovers that we've sent don't have a whole lot of power on board. So most of our rovers have been powered by solar power. Mars Curiosity, which is the newest rover on Mars, is powered by a small nuclear reactor. But there's not enough power there to move very quickly because the batteries will drain and they take time to be charged. The other reason that the rovers move slowly is because they're very far away. So if a rover gets stuck or hits something and breaks, there's nobody there to fix it. And these robots represent a lot of investment in dollars and in time. So before the robot's able to move, there's a lot of different checks that are done, a lot of people who are involved in making sure that the robot will perform a safe action. So you can think about these robots as operating as safely as possible under a sustainable power consumption. And the idea for this is that they will continue to operate for years instead of going and burning their batteries out or making a mistake and getting stuck.
There's one other factor that comes into play here, and that's that because the robots are so far away, it takes a long time to get signals to them and to get feedback from them. So if we commanded a rover to move forward a couple of inches, for instance, it might be as long as 20 minutes or more to get an answer back from the robot that indicated that that move was successful. So we don't want to go too far with these robots at one shot.
Hi, my name is Josh. I go to Hawthorne Elementary. I would like to know how many planets have robots been to?
So we've sent robots to all of the planets. We've flown past all of the planets. And Pluto, which is no longer considered a planet, New Horizons will be visiting soon. We've landed on Venus. We've landed multiple vehicles on Mars, including some rovers. We've landed on the Moon. We've landed on Saturn's moon, Titan. We've landed a probe there. And we've also sent probes into Jupiter. which is a gas planet, so we can't really land on it, but we have penetrated the gas. So we've really been, when you think about robots, we've been to all of the planets, and now we've been to several asteroids as well as a couple of comets.
Dean, before we run out of time, let me ask, why did you pick a job working with technology?
I've always enjoyed technology. When I was a student in high school, I started designing the first products that I sold, and beyond that, I've just enjoyed creating things. That's being an engineer. Every day I get to creatively solve problems, and that's very rewarding.
And Josh, as someone who's interested in working with or designing or building robots, what should he or she study in school?
So robots are machines, and machines are normally built and designed by engineers. To be an engineer, you need to know a lot of math and science. You don't have to necessarily really like math. In fact, most engineers that I know don't really like math. They think the math is something that they have to do so that they can build things. What you really have to be an engineer is an interest in understanding how things work and the patience to learn how things work. So what I would tell students who are interested in getting into building robots is to pay attention in school in all subject areas, and remember that math and science, even if it's a topic that's not very interesting to you directly, that is what we build all of engineering on. If you don't understand how the world works, you can't understand how to build something that is going to work in the world. And then you can go off and you can start working right now. You can build whatever you want in your parents' garage with their permission. But there's nothing that says you have to wait until you have a degree from college before you can start building robots. You can start building robots whenever you want.
Yeah, absolutely. Get involved in the robot programs that are available to you. FIRST Robotics has programs called FIRST LEGO League that start all the way down in kindergarten and go up past 7th grade. FIRST Tech Challenge is for junior high and senior high students, and the ultimate robot competition, the FIRST Robotics Challenge, is for senior high students, and that's where you get to build the really big and wild robots.
I'm sorry we've run out of time. Thank you for answering students' questions.
Thanks, it's been fun.
It was good.
Our thanks also to the folks here at Micron for hosting us. Now, do you have a question for an upcoming show? You can email it or send it as a video question, recorded on your cell phone, tablet, or webcam. And if you're an educator, we'll even lend you a camera. And if you send in a question, you and your class can win prizes. Our last prize winner was Braden in Mrs. Hunt's class at Cynthia Mann Elementary. So to find out about today's topic, go to the Robots section of the Science Trek website for facts, links, lesson plans, and more, or watch Science Trek the web show. So send in your questions, and each week, check out my blog for the latest science news for kids. You'll find it all at idahoptv.org/science-trek. Thanks for joining us. We'll see you next time on Science Trek.
Presentation of Science Trek on Idaho Public Television is made possible through the generous support of the Laura Moore Cunningham Foundation, committed to fulfilling the Moore family legacy of building the great state of Idaho.
If you want to learn more about this topic or watch our videos, check out the Science Trek website at idahoptv.org/science-trek.